So what's the deceleration if there's an incline? So, well, first let's try to find the coefficient of static friction. So for part A, we have the acceleration, the maximum deceleration being negative 3.80 meters per second squared, and then we have this free body diagram. We have the mass of the car, force normal, and then pointed down is mg, the force of gravity, and then pointed to the left, or opposite of motion, is force of friction. So we can say that for part A, rather, part A, sigma f in the y direction equals 0 newtons. So we can say that the force normal equals the force of gravity, or mass times gravity. And then we can say that the sum of forces in the x direction simply only equals negative force of friction. And this is equaling ma. This is going to equal mu s mg. So it'll be this coefficient of static friction times the normal force. In this case, the normal force is equal to the force of gravity. Therefore, the force of friction equals the coefficient of static friction times mass times gravity. And we can solve. So the masses cancel out, and mu s equals a divided by g. So this will simply be equal to 3.8, or negative 3.8 divided by g, so negative 9.8, and this is equaling 0.388. So this will be our answer for the coefficient of static friction. And then for part B, they're asking us what is the acceleration if it's on an incline. So let's draw this incline. We have here a theta, an angle measure, a mass of the car. Force normal is always perpendicular to the surface. Force of gravity always points straight down. And then, of course, we have a force of friction always opposite the direction of motion. So we can say that for part B, theta equals 9.3 degrees. And then we can solve for the sum of forces in the x direction. Again, we're choosing new Cartesian axis, so this will be our Cartesian axis. And so sum of forces in the x direction will equal negative force of friction minus the x component of gravity, so mg sine of theta, and this is equaling mass times acceleration. We know, of course, that the force of friction equals mu s mg. So we can say that the acceleration is going to be equal to negative g mu s cosine of theta plus sine of theta. We can solve and say a equals negative 9.8 times 0.3878 cosine of 9.3 degrees plus sine of 9.3 degrees. And we're getting that the acceleration is going to be negative 5.3 meters per second squared. So this will be our deceleration, our maximum deceleration up this incline. That is the end of the solution. Thank you for watching.